Hi, good afternoon, everyone. Thank you for joining. Today we'll be talking about design exercises for cloud architects, and I'll be presenting some of the new things that we're building on architecture that we see every day in our common workings with our customers and in the field. So without further ado, I'll introduce myself. My name is Ben Biley, and I'm a solutions architect with Aviatrix. And I have a background in healthcare and manufacturing, and also from the partner space. And I wanted to go ahead and get started and go ahead and begin on our exercise here. So I expect everyone to be pretty collaborative, and we'll go through a couple of the ideas here that we'll be talking about and kind of lay down a foundation of what we're looking for, and then try to build it with cloud native concepts. And then beyond that, we'll go ahead and see how we can achieve that same result and meet those requirements on what our customer, in this case it's a hospital system, what it's going to look like with Aviatrix in place as well. So I'll go ahead and get started. So we have a company, it's actually a healthcare company. It's a national healthcare provider. They are, responsible for the well-being of their patients, and that's their top mission. And of course, security is at the top of their list. Some of the main things they do as a hospital system and a healthcare provider is that they're heavily involved with the EHR, or electronic health records, and EMR, which are the electronic medical records. And so, inside of that, there's a lot of heavy data utilization, a lot of intense throughput requirements, and so speed, latency, all of those things come into play for getting patient care to the levels that they're looking for. Specific metrics that they're looking for are being tracked as like a time to diagnose, or something like an HPPD, or hours per patient day. When we're looking at ratios that nurse to patient, or doctor to patient, those are the things that they're going to be looking at, and we want to make sure that we can improve those types of metrics, because it has a direct business impact to our hospital. And as a part of some of their new initiatives, they have some new applications that are being deployed around analytics and translation services, as well as a new prescription application that's going to be released soon. So some of the details around that will be coming out. That specific application is going to be slated for GCP, and there it is. And so the application today lives in their on-premise data center, and they're going to be moving that to GCP. So part of this design exercise is going to be looking at the technical requirements here that are coming up, and also building that out, and meeting those requirements, using cloud native. And then after that, we'll look and discuss and see what we can do with Aviatrix to meet those requirements as well. One of the last requirements here is that, there's also a legacy hospital system that was acquired by Excelicare in the past year, but the network team has been always working on it. It's been a continual nuisance in the fact that they've had to do a lot of manual effort to get a lot of their connectivity in place, just because it's like an M&A gone wrong with overlapping IP addresses. So I'm sure a lot of us can relate to those types of scenarios where there's just a lot of manual processes around firewall rules, NATs, and routing as well. So we're going to be looking at some solutions that can help address that and meet that requirement. So today, Excelicare is using AWS as their main CSP, and they're using it in a multi-region fashion, so like US East and US West. And their plan is to go into GCP with their application that they have, and they're moving to GCP because of the translation and analytics services. Currently, though, they have TGW and AWS, and all of their apps and data across several data centers are held in those different regions, right, cloud adjacent, and each of them has, each of their data centers today has a 1 gig direct connect to AWS. The plan is to go into 1 gig interconnect to GCP, so they can have a direct connect or a more direct connection to those resources from each of those hospitals. One of the other requirements that we have coming up is that we want to have AWS and GCP to be interconnected in a very secure way. So think encryption and how we would unify that. We also want to make sure that we have some level of segmentation, whether that's something with like a firewall or an access list or something like that. Just looking for ideas that you have around how you would isolate and segment that type of traffic in the cloud, and VPC to VPC, and also across the different CSPs themselves. And then next, we'll go ahead and talk about the LHS, or legacy hospital system, and their overlapping IP addresses, and where the conflict really exists, and how we can potentially overcome that using cloud native, or a combination of cloud native and some of the ideas that you have. And we'll also look at some of the existing security rules that AWS leverages, or that we will leverage in AWS to segment the network. So there's a lot of manual effort today with how the hospital system is securing their traffic, and it's through a lot of manual security group manipulation. So very labor intensive from that perspective. We'd prefer to see something that orchestrates that from a centralized perspective. So if that's a firewall platform like a Panorama or Palo Alto, or another similar type of architecture, looking for something and ideas on how we would centralize that type of architecture. And it could be something that's really not based on a specific application. It could be something that we're leveraging through infrastructure as code, for instance, would be another option. Also, this is sort of a reiteration of a second or third bullet point here, is that we want to make sure that there's segmentation. So we're restricting access to the 3 different VPCs that exist in our regions in AWS and across over to GCP. So we want to make sure that we have the capability of segmenting those prod, staging, and dev. And to that end, it does say that we do leverage manual security groups to facilitate that, but again, your input on how best we can meet that requirement will be what we talk about. And lastly, what we're looking at here is, what kind of logging and visibility would you recommend in this situation? Because right now the hospital system is really kind of at a loss for how they can get that visibility without spending an arm and a leg. Currently they're using flow logs and a combination of third-party services to get that, but some of it is not ideal, and it's very expensive. So having something that's normalized and is capable of providing that visibility across AWS and GCP, ideally in a single pane of glass, or something that's managing both of those environments or has that visibility, would be ideal. So let's go ahead and take a look at what the architecture looks like in their particular environment today. And so right now we can see that we have 2 different regions. We have US East, and we also have US West, and we have connections into our on-premise network through direct connects. And in this particular design, we have 3 different data centers, the legacy healthcare East data center and the West data center. Inside each of the VPCs, there's a hub and spoke architecture today. So we're using TDW and attaching our prod, dev, and staging. And it's pretty much the same thing over in US West. So one thing you might notice is that the CIDRs or IP addressing space that we've allocated, to this cloud space, it does overlap with what we have in the healthcare system, the legacy healthcare system. So one of the challenges here, as I brought up earlier, is overcoming that type of connectivity, overcoming that overlapping IP address as the connectivity from the legacy healthcare system goes out into that resource in the VPC and US East one. And just a list of what we're looking for is that we're looking for some of the challenges today that we see are that the traffic is between VPCs. It's not encrypted. Traffic between on-prem and the VPCs is not encrypted, and we're looking for suggestions on how to meet the requirements as we talked about before. Also reiterating is that we don't see any segmentation really. There's nothing that's really preventing, other than the security groups there, which are subject to a lot of the, I guess, human error, for lack of a better term, in configuration. So there's a lot of manual processes in this network that kind of get it functioning, and there's really limited visibility as the traffic flows in and out of that TGW and from VPC to VPC. One of the other challenges that there's also in this environment is that the team that's responsible for the day-to-day care and also operation and also design and build, they have not seen GCP in the past. And so now that management has decided to move forward with GCP as their analytics and home for their application for prescriptions, now they need to find a way to manage that, so and be able to put that into production. And so there's a huge learning curve from that perspective and a big skill gap. So we'll go ahead, and I'll be the facilitator here, but we'll go ahead and talk about some of the things that we're going to try to put in place using cloud native. We'll show the screen with the basic connectivity and the basic VPCs that we'll see, and try to get input on where we would build this and make that connectivity. So we'll look at availability, manageability, performance, security, cost optimization, those types of points, and see where they fall in. And we're going to be placing them in a diagram. It's part of the multi-cloud network architecture. And what's going to be shown here is the top layer. If you're familiar from days gone by of our data center networks, not that far back anyway, but if you remember core, access, and distribution and those types of layers, what we're trying to do is create that sort of analogy to in the cloud, and we have the same type of design in the different layers. So we have a core and access, and we also have that other security layer here on the top here. So what we'll go into here is just an overview of what MCNA looks like. So when we're talking about the application layer, that's the very top layer, and that's where your VPCs, your VNets will live. And that's where the applications live, wherever the instances live, and that's that top layer. When we're talking about the core of our transit and the core of our network, our backbone, that's going to be in the global transit layer. So that's going to be very important on how we build that connectivity. whether it's through a native construct like a TGW or peering, those are different options that we have in our bag to sort of use as a tool to build this out. Additionally, we have the cloud access layer. Now that's the connectivity into the network from on-prem, third party, really anything outside our edge. And we can see those edge type connectivities can range from branch offices all the way through to other clouds or other data centers, things like that, partners, even remote users like VPN. And this is an example of what that would look like when we were putting those types of functions into those sort of placeholders. We can see where the core access is going to be positioned here on the bottom here. And then we have our transit here in this particular mid layer. And then at the very top, we have where our applications live in our cloud access. And it doesn't matter what cloud we're in, whether we're in Azure or Google, but in this example, we're going to be focused on AWS and Google. Here we're going to just show that the multi-cloud networking architecture is something that's scalable. It shows a precise place where we have all of our connectivity identified, whether it's connectivity inside the cloud, connectivity through the cloud, or connectivity or from our instances. And inside of that, one of the foundations of the architecture is to have this level of visibility and control, whether it's on the build side day one, or we're looking at day two and operational things like that. Okay, so now we're at the point where we have a look at what we have in AWS today and what we're looking to put together with GCP. We have the CIDRs identified, and we also have the connectivity it's pretty vanilla as it is right now. So I think the next step here is to kind of go over those requirements. I think one of my colleagues will be putting it in the chat to kind of refresh your mind on what some of those requirements were, and just like to get your feedback on how we would kind of build this up using cloud native today. And if anybody wants to just speak up, I guess we can allow you to go ahead and add something to the chat, and then we can go ahead and raise your hand like Davina pointed out here, and then we'll go ahead and just listen to what your design recommendation might be to meet one or multiple requirements that are part of this design. Looks like Igor had a question. It was around how is on-prem to multi-cloud segmentation achieved end-to-end? Is locally at each DC ingress, or are we relying on the VRF light handoff? And I think when we're talking about segmentation, right now we're focusing on the type of segmentation you can do natively. And, that would be, using different constructs in each of the different CSPs. So if you'd like, you can kind of join the conversation, or we can look to see, before we go into the detail of where we get into multi-cloud segmentation, we can add on to that with an Aviatrix. I think Temi had a good recommendation here. We can set up a hybrid connection between AWS and GCP using site-to-site VPN. Right. So in this particular case, what Temmie's recommended, so from our on-premise, oh, you're talking about a hybrid connection between the clouds themselves, yeah, like from a VGW into one of the gateways over in GCP. Okay, yeah, I think that that's one way to get that direct connectivity in place, and that's a standard IPsec connection that we build out in one of the clouds. So we would have our VGW, built up, and then that connection, we go ahead and mark on here. You can see, and then we would have another connection here. And we sort of, what Temmie is recommending here is that we build that connection to sort of bridge from one region to another. And Temmie also adds, in the AWS transit environment, we can set up a transit gateway for east-west connection. Okay, creating attachments for each of the different connections. Okay, so that's what they have today. So that also meets the requirements of having the connectivity that they're looking for from east to west.
So what I'm trying to say is there are two ways to look at it. If they have a transit gateway existing now, we can set up a VPN on that transit gateway and connect it to the GCP itself.
Right.
Or if you want to use the Aviatrix solution, we can just drop gateways in the AWS environment and what's it called, and GCP, and just link them up itself using multi-cloud architecture.
Right, and that's a great recommendation, and I think we'll see an option of that or some flavor of that in the subsequent slides. But yeah, with cloud native, you're right on track there with having the TGW, having a VPN attachment where we would connect one cloud into another or into our on-prem network. So wherever that destination is, we would build up from the TGW. That's, go ahead and draw that out here. Yeah. So from our TGW here, we would, connect each of these together and then also create a VPN attachment from that TGW all the way over to our gateway in the GCP. And so that gets us into one aspect of the connectivity where we want to have the connectivity directly between GCP and AWS. We'd also have to repeat this and do the same thing over here and make sure that we had another VPN attachment go over to GCP as well. So we have more to manage from a routing perspective and connecting them to. I think as far as those requirements, we're meeting those. Rajat also talked about having an interconnection between GCP and AWS using like an Equinix partner, right? So you can have that underlay available to you, but you'll need to be able to terminate that, in the form of, a direct connect or a cloud interconnect, and then you can bridge those together. So, and I think with Equinix or another underlay like a Megaport, they might have that solution where it does the routing for you between them. And so you have to go in through that Equinix transport to get from one to the other. But a very similar type of design where you do those types of underlay connectivities. And as far as looking at what we're creating the segmentation between VPCs and also from VPC to, I guess, GCPs, VCPs, VPCs, yeah. What are some recommendations that you have on, isolating those? Okay, I see Igor said creating different route tables in the TGW. So yes, starting off at a layer 3 level is probably a good start, and controlling route propagation, correct? So you can sort of isolate or join based on that route propagation and what you're controlling to go through your network. So I think that's a good start into how you would be able to build that out and facilitate that sort of level of isolation. What about like improving on that recommendation, Igor, and looking at for connections where you do want connectivity, but not everything. So you want to have the layer 3 connectivity between your VPCs, say your prod VPC in one region and or your prod VPC in one region to like the staging VPC. How would we secure, specific application traffic or other traffic on top of that? Okay, exactly. NACLs and SGs would be good. It's NACLs are very good in that they're stateless. So, if we're looking to really, keep connections, blocked at a specific level, we can do that. But if we're looking for something that's more stateful, security groups would be the answer to that. And we'd only have to apply it once instead of on the NACL side where we have to do inbound and outbound. Right, I agree with you, Igor. And for this type of design, when we're talking about the connectivity that we have today, so we have the data centers here on the bottom. This is our legacy hospital system. And then there's also a connection into another hospital here, and then their other hospital on the east over here. And each of these has a connection into, it's over here today. So they're able to connect to their direct connect gateway or, and then get to their resources. Once they're in there, we have this connection. One of the requirements was more around the legacy hospital system and it having an overlapping CIDR with, this region here at the top. So on a previous slide, I had the same sort of CIDR. It was 10.10.0.16. So with the same /16 or a component of that lives within the legacy hospital system, what would you recommend to be able to allow the connectivity from the hospital system into the cloud so they would be able to access those resources? So recommendation here from Igor again is deploying a one-arm router, doing some SNAT there on the router. That's also a good recommendation. We can even take it further and do a policy NAT or a type of NAT on our firewall inside the hospital that's connected directly with the direct connect into the infrastructure. We can do NAT there, but yeah, NAT on the on-premise is really our only option right now to be able to facilitate that connectivity. And it's really not ideal having to make a lot of different changes every time, an app needs connectivity from the affected subnets that overlap. So that is one way to go ahead and meet that requirement. Right, yeah. There's a lot of design considerations around availability and NAT exhaustion the maximum number of connections that you can have per IP address. So when you're looking at that type of connectivity through a large system like we have with this particular design and this particular customer, those types of considerations, you might need to do a NAT pool, and you might need to manage that and kind of keep eyes on it so you're not running into limitations that Igor referenced. One of the other components here is, what other types of capabilities in securing the environment are available, from the cloud side to restrict connectivity from one VPC to the other, or one cloud to the other. And I think natively there's really not much other than what networks you're allowing over your VPN to sort of restrict that, from the AWS to GCP side. But when we're talking about east-west traffic inside of the different regions, what are some of the ways that we can use our TGW to create that connectivity and maybe force it to a firewall? And there are a couple documents out on the internet that are quite large, actually, but they're in reference to how you can use your TGW and attach specific firewalls to those TGWs. And then, by using your route tables for each of those attachments, you're able to funnel traffic from one VPC to the other. And you just have to make sure that you have the corresponding routes on each side, not only the route table of the source machine, but also a return route and path on the destination. So there's a lot of manual effort there when it comes to building out that type of solution. Are there any other suggestions on how we would restrict that traffic using cloud native? If not, maybe another component of that would be, how can we add visibility on top of that connectivity? So if when we're going from VPC to VPC or VPC into on-prem, how do we have eyes on that traffic? What are some of the ways that we can use inside of AWS today or GCP to see what traffic is going across our network? Okay, yep, Vpc Flow Logs. Looks like Temi and Igor talked about that, and having that in S3. So that's one way to do it. In this particular use case, the hospital system had flow logs enabled, and they were also using third-party services, which really increased the cost exponentially with respect to creating that observability, the visibility inside of in each of their networks that they've built up here in AWS, as well as in future state with GCP. So being able to look at that type of traffic, whether it's syslog coming from different components in your network, if you're using specific services that can generate that, or if you're just interested more in like the net flow inside your network, how are you going to be able to not only ingest that and store it in an S3 bucket or in some sort of storage mechanism? Maybe you have a third-party service like a Panorama or something like that, but it's got to go somewhere. And then from there, you have to use either that service's pane of glass to sort of troubleshoot and get visibility on your network and understand it better, or incorporate that data and export it into another program. Maybe it's like a third-party service like a Splunk or something like that, and you can get that same get the visibility that you're looking for. But it's not without hand holding the data and doing a lot of manual effort to get that connectivity in place, and also exporting those logs from each part of your network. Okay. So that's Igor recommended deploy Cisco StealthWatch Cloud. I haven't heard of that before, but that is also a good recommendation. That's another option too, as far as the connectivity goes, to build connections using Cisco's, CSRs and those types of routers too. But I'll go based on what recommendations you have. And to, I guess, maybe Igor or Timmy, you can elaborate on this, or anyone else, the floor is open. What options do we have to, bridge the connect or create the connection from our on-premise network into GCP today? I think Timmy might have alluded to it earlier, or Igor. But we'd want to leverage the same type of transport that we have with our direct connect. Maybe we have our direct connect provider through Megaport or Equinix, and we're using that cloud exchange to get from one place to the other. But yeah, we'd like to establish a VPN or create an interconnect. The problem with interconnect and direct connect, natively they don't support encryption over end to end. So when you're talking about, from one application on premise to a production VPC, that traffic is not going to be encrypted all the way through. And so that end-to-end encryption is a tough one to solve. And there's a lot of, I guess, options, or there's few options when it comes to securing that connectivity. Some might say that MACsec is the solution, but it really doesn't, it's not scalable, and it's really not, infallible. And I don't think that's going to give you the end-to-end solution. And it's only supported on specific types of connections as well. And then, yeah, Fossil recommended Equinix, IPsec using VGW. Yep, and there's also significant costs, as Igor mentioned, when you're using Equinix. Yeah, and in this particular case, this hospital system, one of the problems that they've been having is the performance, is one of them of their EMR application. So when they're looking up images on their workstations, it's taking forever to load. And it might be that the bottleneck is on the connectivity itself from the direct connect. And the only other option on top of that is to increase the direct connect speed. But you can go from like a 1, 10, 100, depending on the type of throughput that's needed. But we're really not going to be able to see, or we're really not going to have that encryption end to end on top of that. So it's not really the type of solution that really meets the requirements on top of that, of what we have talked about. Okay, and then Igor mentioned that some SD-WAN vendors offer some compression, so you can have those on your edges inside your access layer inside this multi-cloud network, and we can go ahead and build that into the connectivity, and that can be sort of our transit. And potentially, it depends on which SD-WAN vendor we're talking about, or whether it's Cisco or Silver Peak, Fortinet, things like that. And then I think one of the other requirements that I wanted to go over to was, they want to make sure that not only that the images are loading fast and they have high-speed links, everywhere in their network, but they're also able to have more direct paths for their network. as you remember from maybe the first page, is that each one of the data centers was connected, singly into the direct connect. And in order for there to be region-to-region connectivity, or potentially with future state of GCP being connected to the network, we'd probably have to hairpin traffic through our data centers in order to get from one end to the other. So we want to really cut down those number of hops and be as direct as possible. And I think some of the recommendations that we heard from Igor and Temi really kind of show, how we can get a more direct path, from AWS into GCP. But again, those links, just like any other secured links, they're limited to the type of throughput that IPsec can achieve. So that's in the 1 to 2 gigabit per second range. It really only scales if you have maybe a third-party device like a Silver Peak, or if you're just doing ECMP. So those are other things to consider, but each of those has their own type of effort to implement, and it's probably not something that I would recommend in terms of the complexity. Let's go ahead and move on really quick, and we can go ahead and look at, what are some of the options that we can actually build through. And so we know where our networks live today, right? In AWS, we have our different regions and connectivities. The type of connectivity that we saw initially was a hub and spoke topology. So that was, having the TGW being that center point for the connectivity. But on top of that, how are we going to build the connectivity? And I think TGW is one way. We can also leverage other native constructs, potentially even peering. But there's specific limitations that you can run into with peering, as well as the number of routes that are going on your network. So it really doesn't scale as well as I'd like to see it. So I think, we can look at, some of the other options here, from Aviatrix's perspective, and how we would solve the problem with Aviatrix and position that connectivity in the network. The first step that we would do is we have to start up a new VPC in AWS. We have to build out a controller, and there's also an instance that we would deploy for Copilot. That's our day 2 operational product. And then from the controller builds out by integrating with the different CSPs, so AWS in this case, and GCP, and building out the infrastructure that we're looking for here. So building on the requirements that we need, the direct connectivity, between AWS and GCP, we're going to start off by building in the core layer our connectivity. So we'll have what we'll have here is one region going directly to another region, but also it's a full mesh in this particular design. So we're able to see appearing from AWS, US East directly to GCP, and also we have the 2 AWS regions peered, and then lastly we have the transit in US West peered with GCP. So it's a full mesh there. So we have the direct connectivity, and we're not having to go through any other intermediaries before we go over that. Let me see if there's any other questions yet. Feel free to bring those up as we go through. The next step is, on top of that connectivity, we need to be able to control that visibility inside of each of our VPCs. And from the controller, we can go ahead and build out that connectivity. And from the VPC level, we're able to build out gateways to do just that. So the goal here is to create a normalized data plane, or create a path that you own that can give you that end-to-end connectivity from not only one region, but multiple regions, even across different clouds. So as you can see, the connectivity looks the same in one region as another cloud, and you're not having to the important thing here, and it's also important for Excelicare, is that they don't have experts in GCP, and they need to be able to deploy GCP infrastructure from, or they need to be able to deploy it or have that expertise and or something that can do it for them. And in this case, Aviatrix is that intermediary and being able to turn our policy into that connectivity. And so based on this right here, we see that, each of the VPCs is connected into our transit. And so we have the application layer at the very top where the VPCs live. We've bridged that into the transit, into a hub and spoke architecture. And now we have a path from one region to another, and also one region to another cloud. And that path is optimized. So we're not having, this is strictly in the cloud right now, but we're able to have a very direct path. And one of the requirements on top of this is that we're able to do, that we need to have high performance encryption, especially for those imaging applications that, were talked about earlier. And so on top of these connectivities, we can actually spin up the connectivities up to 60, 70, 90 gigs of throughput inside one particular cloud. But, the scale is much in advance of what the CSPs can support natively. So across clouds, like from AWS to GCP, or even AWS, one region to another, we're talking 15, 20, 25 and up throughput. And that's leveraging the connectivity of a transport. If you have a Megaport or an Equinix, you can use that underlay. But the underlay that that we're using is the backbone of AWS. So that's one step closer to the workload. Why not use it? Igor has a question here: is how is route propagation achieved across participating tunnel endpoint routers? So your Aviatrix gateways. So the controller, it programs the routes, based on your security policy. So each one of our VPCs is connected to a security domain, and we create our connection policies with those security domains. So we can say that prod is allowed to talk to staging, but in that particular grouping, we're not including dev. And so because of that policy, the controller, it puts that into each of the gateways, and prod, it does not see or cannot talk to dev at all. It can only talk to staging, and vice versa. And it's a software defined connectivity. So the controller is making those and propagating those routes. In the case of the gateways talking to each other from the transit. So you have more granular capabilities, when we're talking about dynamic connections. So when you're terminating like your direct connects or your express routes, interconnects into the network here, you can actually turn on route approval. So you can pre-approve, a specific CIDR that you want to come in your network, or you can specify, or you can just wait for advertised networks to come in, and then you get an email that, hey, this network is being advertised from this particular third party or your on-prem network. Do you want to allow it? Which is great, so you don't have a black hole route that can disrupt your network. I'll go ahead and continue here. I know we're running a little behind here, so let me go ahead and continue here. When we're talking about the overlapping CIDRs that we had inside of the US East region and also our on-prem network, one of the options that we have on our gateways is to provide the capability of doing source NAT, destination NAT, and also doing mapped NAT, which is like the easy button when it comes to NAT. So there's different ways to do that and to do it easily from the Aviatrix perspective. So in the case of the connectivity from the legacy hospital system, there is no change that they would need to make when accessing those resources. The gateways would create a policy, and then the specific NAT addresses that they would have to use would be given to those users that were from the legacy hospital system, and they would use those IP addresses instead. So there would be no configuration necessary, but they would have to use sort of a virtual CIDR or virtual IP address that would be advertised inside of the Aviatrix network. And also the capability of doing like a one-to-one NAT or a source NAT is also capable on any part of the network. Very flexible from that perspective. And once we've built out this infrastructure, one of the great things about it is that we're able to see what the topology looks like right away inside of Copilot. So Copilot will give you that 10,000-foot view of what our VPCs and regions look like. And you can actually troubleshoot from right here. You can type in any type of search criteria into the search field inside the topology view. And it'll look at metadata, IP addresses, a number of different things, and you can find out where things live. You can even run captures at specific locations in your network, which if you've ever done that inside of any of the CSPs like AWS or Azure, you know how long that can potentially take. And as a result of building out this archetype of architecture where we're creating our data plane from one VPC into the transit and then across to different CSPs like Google, in this case, we're able to, one of the big byproducts of that is having the visibility. Now you know what's going on your network. You have the NetFlow, you have the syslog from each of the gateways that's part of that data path, and you're able to see exactly what's going on in your network. We can also look at specific segmentations that we have in our network and get that in a visible format rather than looking at the controller or inside of Copilot directly. I'll go ahead and touch on this really quickly, but there's other security features that are embedded inside of each of the gateways. When we talk about security, we have Threat IQ, Threat Guard. Those are our like an IPS, IDS type functionality that can look at malicious IP addresses that might be coming into your network or going out from your network, and that'll be correlated with a trusted database. And if it matches anything that's deemed malicious, it can alert you, or it can actually block based on your approval of that. So it can be an automatic function as well. And the great part of that is it's happening right there on the gateway. It's not having to use up resources on any parts of your network or on your data plane. It stops it right there on the gateway. And lastly, this is what the connectivity would look like if we were building out the connectivity from each of the data centers out into the different transits and having that connectivity at a high rate. One thing I've depicted here is a cloud end appliance here at the bottom here, which is it's a virtual device that it's our edge device that will create the connectivity at line rate encryption into over the direct connect and be able to get you, whether it's 1 gig, 10 gig and up, or multiples of that, we can give you the type of line rate encryption from your on-premise network into the cloud. So that's able to go, into really any place that's running or that you have that type of appliance. So after that, that's pretty much the last slide from that perspective. And this is really what the design would look like to meet all of those requirements, where we had best path selection. We're not hairpinning traffic. We have direct connectivity between them. And so because of that, we're having reduced latency, and we're also using bigger pipes when it comes to the connectivity inside of our clouds and to our on-prem network. We're not limited by IPsec or those types of 1.25 gigabyte throughputs anymore. We're able to scale much higher than that in that throughput. One thing to add is, and I don't know if Davina had already put it out, there's a poll that will be sent out, and hopefully everyone fills it out and is able to give their feedback here. And what I have on our screen here. Oh, did someone
Hey,
have something
Ben,
to say?
yeah, this is Davina. We have a couple great questions in the chat if you want to take a look at that. I think Emmanuel has a question and Igor. So if you want to take a look at that, if you want to answer those live.
Oh, sure. It says, I think Emmanuel said, what determines how many transit FireNet VPCs Aviatrix would be able to support in my cloud account? There's really no upper limit right now. I think it really depends on instance sizing. So when you get into, if you have 100 VPCs or 1,000 VPCs, we can come up with a solution that can manage all of those. We have customers of all sizes, whether it's 50 VPCs like I mentioned, 1,000 VPCs. And it doesn't have to be all in AWS or GCP. It can be a combination of Azure or OCI, Alibaba. The controller is that central point for that connectivity. So we can take that offline to Emmanuel if you're looking for specifics around a specific number.
Yeah, just to add on that, that also depends on how you want your traffic to be basically analyzed by a FireNet. You can use, centralized FireNet or FireNet in each transit VPC. That really depends on how you would like to control your traffic, both coming in and going out of your VPCs. And I agree with Ben, there is no, upper limit on it.
And I think to Emmanuel's question also is like, how many transit FireNet VPCs would you want to build? Well, I think to the point that was just mentioned, yeah, you can separate it out with east-west traffic on one set of FireNet, or one set of one FireNet, I should say. And then you can do north-south on a separate pair of firewalls or group of firewalls. And in each situation, in each VPC, we can scale up to 20 different instances of firewalls. So the throughput that you can imagine from all of that is amazing. And it's really just a question of, what are your requirements? And then, we just pick the instance that does it. Igor also mentioned, are there any QoS mechanisms available to prioritizing apps within individual gateway-to-gateway tunnels? QoS, I don't think is something that we have on the table yet. Right now we have different knobs when it comes to like the routing, but we're working on building in as we go up the layers on those types of functionalities. Another question from Ibrahim. Can we send NetFlow from other routers and firewalls into the network into Copilot? Right now, I think Copilot is just for the gateways and the controller themselves. Okay, and another question from Gabolan. How do you enforce governance across using Aviatrix? And I think the answer to that is in the controller, you set up specific policies with regards to your connection policies, and you can isolate, segment, or group different VPCs together. And whether that's at the VPC level or at the subnet level is something that we have in its first iteration available today. And then just really quickly, I know we're pretty close to the end of our time here. The future state compared with the before and after is what I'm trying to say. You can see where we were and what type of connectivity this hospital system had at one point and what the limitations are to the network that they were able to step around by using Aviatrix and create a more visible network. I think that's and more understood network, but also create something that can be repeatable across different regions and GCP, different clouds as well. And so just to summarize, we've created that repeatable architecture, and we've also enabled encryption everywhere from on-prem into the cloud, as well as everything in between VPC to VPC, VPC to on-prem, etc. we've also done high performance encryption to kind of meet those latency and throughput requirements that imaging can, give to our network. So we've met that, and we've also enabled segmentation from the VPC level, and we've also integrated HA as a really a consequence to how this design of MCNA and connectivity that we've built up. So this type of architecture is the sort of the standard when you're building out your cloud network and being able to scale, regardless of what types of connectivity you have. There's always a placeholder inside of that layered topology that you can place your traffic. And the capabilities on each of those spokes and part of that data plane just continues to increase, whether it's from a security perspective or just visibility. So I think those are the big points there that we can add, not to mention NAT like we used in this particular use case. And lastly, leveraging Copilot to kind of look and gather that data for us and show us all what that looks like, from a NetFlow perspective, from visibility perspective, getting a picture of what our network looks like and how it's behaving. And lastly, just go over the main business value framework that we have at Aviatrix and how we accelerate your cloud journey and increase control, visibility, efficiency, reducing risk, and contributing to a lot of compliance requirements like HIPAA, high trust, things like that. And then lastly, bridging the skills and talent gap, just like we saw in this example. That's really important to see how, even without expertise in one cloud, we were able to deploy infrastructure through Aviatrix and build out that connectivity from one point of the environment in the controller. Lastly, I wanted to just add, as we come to a conclusion here, we do have another chat coming up, the Tech Talk on the 24th about Zero Trust. And we have those every Tuesday. Additionally, if you're looking to get more hands-on, we do have specific build sessions. We also have them, Flight School is another version of that. And we also can do one-on-one time to discuss architectures and just talk about what your plans are for the future in your cloud journey. Lastly, one of my favorites is the ACE program. So if you're wanting to learn more about the cloud, whether it's at the associate, professional, or expert level, or are already familiar with the platform, this is a great way to start and continue your learning. And also from an operational perspective, there's a module for that, and infrastructure as code. So there's a lot of different ways that you can leverage that. And thank you to everyone for joining. Really appreciated you participating, and hope you have a great rest of the day and great rest of the week. Thank you.